Okay, let's give you guys some more practice. So given this function here, f of x equals this thing here, work out if this is an even function or if it's an odd function. Okay, and when you come to plot this function here, it will look something like this. Okay, so yeah, it will look something weird like this here. Well, have a quick. Well, imagine you didn't have the graph. So you don't. Well, looking at this graph here, if you reflect it, remember to decide if a function's even, you would reflect it. So inside your mind, if you have access to a graph, then inside your mind reflect it along the y-axis. See if the reflection equals the original function, and then to decide if it's an odd function, then rotate it. Yes, you could do this, and then you could do this. See if the two are equal. Or a quick way is to try and rotate it 180 degrees and see if the rotation is exactly the same as the original. So yeah, but in this case, imagine you didn't have access to the graph. So this is all that you're given, okay? And here you got to decide if this is an odd or an even or neither. And another thing is looking at this graph here. There's an asymptote here, and there's an asymptote here along here. Well, if you look at this here, remember in maths, anytime you have 1 divided by 0, the whole thing here breaks down. So if this whole bubble here is 0, then the whole thing breaks down. Okay. Well, when is this 0? Well, this is 0 when this thing here is 4, positive 4, because if this bubble here is 4, then 4 take away 4 will be 0. So the whole thing breaks down when this thing here is positive 4. So when is this thing positive 4? When it's 2 times 2, that's when it's positive 4. So this here, well, when this bubble here is positive 2, then the whole function breaks down. Yeah, when this bubble, when this x squared here is 4, then the whole thing. So when this bubble here is 2, then the whole thing breaks down. Meaning that when x is root 2, then it breaks down. Or when x is minus root 2, then the whole function breaks down. So basically, for me to correctly state this function here, I should say that, well, this function, I've got a function here where x can be any real number, okay, but it cannot be x cannot be root 2, and it cannot be minus root 2. You see, this is a correct way of me writing the whole function here. But I just want to keep things simple. I'm just going to say we've got a function here like this. Establish if this is an even or an odd function or neither. Okay. So remember, you're given this function without the graph here. So you've got to decide here. So basically, apply this transformation and check if these two are the same, and then apply this transformation and check if the two are the same. Well, anyway, press pause and have a go. Okay, so let's check this. Let's apply this transformation here. So wherever you see an x, we're going to put minus x into here. So we are now going to apply this transformation. So given this function here, we are going to apply this transformation, f of minus x here. So we are going to put minus x into this thing here. So so this will be 3 over 2, and then it's going to be negative x squared. Okay. Yeah. So here you've got a bubble, and then you times 2. Okay. Well, minus 4 here. Let's tidy this up here. We've got to do this first because power is more important than multiplication. So when you square it, it will become positive x squared. So the overall the whole thing will be this: 3 over 2 3 over 2, and then it will be x squared, and then minus 4. You see, after applying this transformation here, this thing is exactly the same as this thing here. So after applying this transformation here, it equals exactly the original function. So therefore, this is an even. Is it possible for a function to be even and odd? So, well, anyway, this is a question that you have to answer for yourself, or develop a way of answering it for yourself. But for this video, let's check. Okay, so we know this function here is even. Let's check if it's an odd, if it's also odd. So let's apply this transformation here. So this transformation here will be the whole thing and then stick a negative in front of it. So let me apply this transformation here. Negative, let me do it down here. Negative f of x here. So that would mean me taking the whole thing intact. Okay, 2x squared minus 4. So it's the whole thing intact, but then I'm going to stick a negative in front of it, because that's, look at this, it's the whole thing intact and then stick a negative in front of it. So this here gets moved. Well, I'm just going to tie it up, and basically it's like that. So after applying this transformation here, the function will look like this. Now let me apply this transformation here. So I'm now putting the negative x into here. Okay, so hang on. I'm going to do it up here. So now I'm going to apply this transformation here. So f of minus x here equals 3 over 2, and then bracket minus x here, and then close it up, squared minus 4. Now let's tidy it up. So this will be 3 over 2x squared minus 4. Now don't forget that this is one bit here, and this here is another bit here. Now we are checking to see if this here is the same as this here. Okay, so let's check. This here is not the same as this here, because you've got a minus here. So basically this is not the same as this. Okay, so therefore it is an even function, but it's not an odd function. But the main question here is it possible for a function to be even and odd? Well, that's something that you have to develop for yourself. Okay, but the answer to this question is it's an even function. Okay.